All right, everybody, how's it going? Today we're going to be talking about work. What does it mean by the scientific definition?
Well, in physics terms, work is equal to an applied force times the direction that you move an object. When you lift something up or you push something, work is equal to the amount of force you applied times the distance that you moved it.
Right, and force works parallel to the object. So let's say I'm picking up this iPad here. So, here we go. If I move it up in a way, I am doing work on this iPad to move it up, opposed to if I'm carrying it just like this and I'm walking with it. So no work is being done whenever I'm carrying or walking with it, opposed to when I'm raising it. The equation for this is work. So we would abbreviate work with the W. Work equals force times distance. So we see it like this. Work is always going to be measured in joules. Simple enough. And then force, we've worked with this before. Force is measured in newtons. And then distance is going to be measured, we've done this before, we've done it last week, we're doing it this week. It's measured in meters. Now, is there another way that we can put this formula?
Oh yeah. My super handy way, you can draw a triangle, just like this, and then you cut it in half, and then you cut this in half. I'm going to put work on the top, and because I multiply force and distance, I'm going to put them next to each other. I can draw a better F than that. And D. So I have my units of joules here, and my units of newtons here, and my units of meters here. So whenever I'm using this triangle to solve a problem, if I'm looking for work, which is on the top, I'm going to multiply my force and my distance. If I'm looking for force, I can divide work by distance, and so on. It's just an easy way to remember it.
Now, work can be positive or negative. So, can you give me an example of a positive force?
How about pushing a cart?
Awesome. How would pushing a cart be work?
Well, I'm applying a force on the cart to make it move some distance. Like when you're shopping in the grocery store, you push the cart down the aisle and pushing it forward.
Mm-hmm. And if, let's say I'm pushing on the cart and the cart doesn't go anywhere, but instead of going forward, it goes straight up. Is that work?
No, because that's not the direction I was applying the force in.
Okay, and force can be measured negatively as well. So force can be negative, and that is not helping the motion. So we think about this kind of like how we did the free body diagrams last semester. So we had our object, and we applied force in a direction, and that was us force applied, and that was going to be like us pushing the cart. Now the negative force, that's us doing positive work. Now the negative work, that is going to be like friction. Friction is going to be the force that acts against work. So that'd be that right there. And I think that about does it. That gives you the equation. That gives you two different ways of equations. That way you can work with this. And kind of gives you an idea about how positive actually works in the same direction and negative works against. You have anything?
Remember guys, friction is a force and is the force that is working against you when you're moving forward. That's pretty much it.
Go ahead and work out a few of these. We're going to start with number 1 on the guided practice problems. It says, how much work is done by a person who uses a force of 27.5 newtons to a grocery buggy of 12.3 meters? So what was the formula again that we're using for this?
Work is equal to force times distance.
Awesome. And again, we've already put up the triangle there for those of you who like seeing the triangle better. So we have force. Which one of these would be the force that we're using?
27.5 newtons.
Okay, so we'll put 27.5 newtons.
That's the force that the person is exerting. Okay, that's the key word there.
And then it gives us a distance. What's the distance that we're going to use?
12.3 meters.
All right, and the equation just tells us that work equals to force times distance. So we would just be multiplying these two together. And when we multiply these two together, what would be the solution?
Let's work it out. 27 times 12.3 equals 338 joules.
338 joules. Again, joules, which is the magical unit of measurement for energy.